What if gravity isn't what you think it is? You hear the phrase, "Does the speed of light cancel gravity?" And it stirs something uneasy inside you, because you know the speed of light is absolute, the fastest limit in the universe. But gravity, it feels different. It feels immediate, unquestionable. You drop something and it falls, no waiting, no delay. So which is it? If light has to travel, does gravity travel too? And if it does, how can the universe hold itself together without lag, without collapse? You begin to sense the weight of the dilemma. It's not just trivia, it's not just a clever question you might stumble on in a late-night forum. It is a crack in the foundation of what you assume about reality. Because if gravity were instant, if the universe could communicate its pull without hesitation, that would break Einstein's rule. Nothing moves faster than light. Not information, not particles, not forces, nothing. Yet if gravity is not instant, if it lumbers forward at light speed, then how does anything orbit? How do planets remain faithful to their stars when the tug they feel is already outdated by minutes, by hours, by years? This is where the discomfort sets in. You are caught between two impossibilities. You imagine yourself holding a glass in your hand. You loosen your grip. The glass falls, shattering against the floor. There is no perceptible delay. The pull is there right away. But if you could magnify time, slow the moment into frames upon frames, could you detect a gap? Could you watch the Earth send its pull upward, taking a fraction of a second to reach the glass? Could you see gravity behaving not as a law that sits in place, but as a signal that must move? And then your mind expands the scale. You stop thinking of a glass and you start thinking of the sun, the star that holds Earth in orbit, that holds Jupiter, Neptune, comets, dust, a whole swirling cathedral of motion. What if it disappeared, simply cut out of existence in this instant? Would we feel the emptiness immediately? Would Earth lurch forward on a straight line the very same instant the sun blinked away? Or would we keep circling as if nothing happened for 8 more minutes, the time it takes light to travel from the sun to Earth? The thought presses deeper because you realize this is not just a thought experiment. This is a test of whether the universe itself obeys causality. If gravity were instant, then information could outrun light. You could know something had changed before light ever told you so. You could know about a star's death before its light ever reached your eyes. Reality itself would crack open and cause and effect would blur. But if gravity crawls forward at the same pace as light, there is a different problem, because orbits require precision. A planet must be tugged toward where the star is, not where it was. If gravity is delayed, shouldn't everything spiral into chaos? Shouldn't galaxies dissolve into drifting fragments, each piece forever chasing the ghost of where its neighbors used to be? You feel the paradox more sharply now. Two answers, both impossible. Gravity cannot be instantaneous, but it cannot be delayed. So what is it? You lie with this thought like a weight on your chest, staring at the ceiling, hearing the silence press in around you. The question stops being scientific for a moment and turns personal, because hidden inside it is something bigger, a question about whether the universe tolerates shortcuts, whether nature allows anything to slip free of its own rules. And so you begin to sense why this question has haunted physicists for centuries. It is not a small puzzle. It is not a footnote in a textbook. It is the kind of question that reshapes everything once you know the answer. Imagine again the Earth moving in its orbit. Imagine yourself floating there in the dark, watching. If gravity is instant, then Earth is being pulled toward the sun's true position, the one it holds right now. But if gravity is limited, then Earth is being pulled toward where the sun was 8 minutes ago. One path preserves order, the other invites chaos. And yet here you are, the Earth still spins, the planets still orbit, the galaxies still whirl in their silent spirals. Somehow reality has chosen a solution that works, but you don't know which one it is yet. You are standing at the edge of the unknown, looking down into the dark well of the question, and it will not leave you alone. Because behind the simple puzzle, does light cancel gravity or does gravity slip free of light, is something even more profound. What kind of universe do you live in? One where even the strongest forces must wait their turn in line, bound to the cosmic speed limit? Or one where there exists a thread, a binding fabric, so deep and strange that it bypasses the rules altogether? The thought lingers. It is not something you can answer yet. It is not something anyone can answer in a single breath. But it is enough to hold you here, awake, curious, uneasy. You close your eyes for a moment. The question plays again. If light has a speed limit, does gravity obey it too, or does it cheat? And as the silence stretches, you realize the only way to know is to follow the path further, to sit with the paradox and let it open itself layer by layer. The story of gravity is not a simple one. It is full of broken intuitions, illusions of common sense, evidence that bends, counter-arguments that cut back. It is the kind of story that demands patience, the kind of story that feels almost like drifting into sleep. You surrender, you follow, and slowly the answer takes shape. So you breathe, and you wait, and you wonder. Because the question is not leaving, it is only just beginning. You keep circling back to the thought. If gravity is bound by the speed of light, why does it feel so immediate? Why do you never notice the slightest hesitation in its pull? This contradiction scratches at your mind like a quiet itch, because you already live in a world where delay is unavoidable. You know it from the way sound takes time to travel. A flash of lightning strikes in the distance, and only after the silence do you hear the rolling thunder. Light itself, the fastest messenger in existence, is never instant. Every sunrise is already old by the time it reaches your eyes. Every star in the night sky shows you its past, not its present. You are never living with the now of the universe, only with echoes. And yet gravity tricks you. It disguises itself as something present, always synchronized, perfectly up to date. Drop a ball, watch it fall. You cannot detect hesitation. You cannot see lag. It is as though gravity stands beside you, whispering directly into the object instead of traveling across space. But then, if this is true, you start to wonder, why would gravity be so different from everything else? Why would nature give every signal, every particle, every ripple the same constraint, but let gravity slip free of the leash? Why would this one force disobey the universe's only law that seems truly universal, that nothing outruns light? The more you ask, the more your mind expands outward, dragging you into scenarios larger than daily life. You imagine yourself standing on Earth, but this time not in the present. You picture the solar system at its birth 4.5 billion years ago. The sun forms out of a collapsing cloud of gas and dust, pulling everything toward it, gathering planets, moons, comets. If gravity were instantaneous, the newborn sun would have tethered all things instantly. But if gravity must travel, then every orbit is a constant dance of delay. A planet is always being pulled toward where the sun was, not where it is. And yet somehow everything holds. The system doesn't unravel, and so you start to sense the shape of something subtle. Gravity might not be what your intuition suggests. It might not be a force, in the way you imagine pulling on a rope, dragging something from one place to another. Perhaps it's stranger, woven into the fabric of space itself. But your intuition resists. You don't like puzzles that challenge your sense of immediacy. You want gravity to be instant. It feels clean, tidy, obvious. It fits the way you live. You don't feel delays when you walk, when you fall, when you spin through the world. Gravity is seamless. Why complicate it? Then again, intuition has betrayed you before. Once upon a time, people believed the sun revolved around the earth. It felt obvious. The sky moved. The ground was still. Why would you believe otherwise? Intuition said so. But intuition was wrong. The truth was stranger. And here, again, you may be facing one of those moments. So you return to the core question. Does the speed of light cancel gravity? The words themselves echo in different tones depending on how you hear them. Sometimes they sound like a challenge. Can the ultimate limit, the cosmic speed of light, impose itself on even the most fundamental bond of existence? Other times they sound like a paradox. If gravity moves no faster than light, then shouldn't orbits unravel? Shouldn't reality slip apart thread by thread? The thought is unsettling, because whichever way you lean, you encounter trouble. If you decide gravity is instant, you've just created a universe where information outruns light. That means causality breaks. The order of events, the very logic of before and after, collapses. You could know about a star's destruction before light carried the message. You could sense the universe faster than you could see it. But if you decide gravity is not instant, if it is tethered to light speed, then you inherit a different nightmare, a cosmos where gravity is always late, always a step behind. a planet pulled toward a position that is already out of date, a galaxy spinning apart because its stars cannot keep up with one another. And yet the universe is here, stable, vast, spiraled, bound, the orbits hold, the galaxies remain. Somehow this paradox resolves itself. Somehow the cosmos has chosen a middle ground, one that both obeys the speed limit of light and preserves order. But that middle ground is not obvious. It is not something you can guess by dropping a glass or standing in a field. It is not something you can feel in your bones. It hides beneath the surface of intuition, waiting for theory, for mathematics, for experiment. And so you lie here, staring into the question, unable to solve it but unwilling to let it go. Because you know deep down that hidden in the answer is something larger than gravity, larger than light. Something about the very fabric of space and time itself. For now, though, you sit with the tension. It is like a rope stretched taut between two poles, vibrating with contradiction. On one side, the temptation of instant gravity. On the other, the demand of a finite speed. Both cannot be true, both cannot be false. The silence of the room around you feels like the silence of space. Still, infinite, yet alive with unseen currents. You close your eyes and imagine the planets swinging around their star, galaxies turning like pinwheels, black holes bending everything toward them. You see it all, and you cannot decide whether the pull that binds them is racing or already there, delayed or immediate. But perhaps the question isn't meant to be answered quickly. Perhaps it is meant to be lived with, carried slowly, like a stone in your pocket that weighs on you without crushing you. For tonight, you let it rest there. You breathe into it, knowing you have only opened the door. The puzzle is waiting, and its pieces will take time to reveal themselves. And as you drift deeper into the thought, you begin to feel something else. The sense that this contradiction, this paradox, is not just confusion. It is a clue. Because if gravity is not instant and not chaotic, then it must be something else entirely. Something that bends your idea of what a force even is. But you are not there yet, not tonight, not in this first step. For now, you let the question hold you, half awake, half drifting, knowing the story is only just beginning. You keep holding the question in your mind, turning it over like a coin, catching different glints of meaning in the light. Does the speed of light cancel gravity? The words echo with a rhythm now. They don't sound like physics homework anymore. They sound like a riddle whispered by the universe itself, a puzzle with stakes so vast you can feel the edges of them pressing against you. Because if you think about it long enough, you realize that this isn't really a question about speed at all. It's a question about reality, about whether the universe communicates through whispers that must travel, or through threads that simply are unchanging, immediate, already there. You imagine yourself standing on a cliff holding a stone. You drop it, it falls, no hesitation, you cannot measure any delay, but deep inside you suspect that this is a trick, that the world feels seamless only because the distances are small, a fraction of a second, too tiny for you to notice. What feels instant might only feel that way because your senses are slow, your body is clumsy, your mind is not precise enough to detect the lag. But what happens when the scale grows? When the question is stretched across millions of kilometers, across billions of light years? You picture the universe expanding before you like a map, the Earth orbiting the Sun orbiting the center of the Milky Way drifting in its cluster, and beyond that, galaxies bound in larger webs, threads of gravity pulling across unfathomable distances. If gravity had to wait, if it had to crawl at the same speed as light, wouldn't these webs collapse into disarray? Wouldn't the cosmos itself fall apart? And yet it doesn't. The galaxies spin, the planets hold, the stars keep their balance, the universe endures. This is where you feel the paradox stretched tight again, humming like a string pulled to its limit. You imagine the sun winking out of existence, not exploding, not burning down, just gone. One instant there, the next instant erased. If gravity were instant, the Earth would know right away. It would leap free of orbit the very same second, hurtling straight into the dark. If gravity were limited by light speed, then Earth would remain loyal for 8 more minutes, until the last note of the sun's pull finally reached it. The scenario feels simple enough, almost childish. And yet it is the kind of thought experiment that forces the biggest questions into view. Which picture is real? You do not know, and that uncertainty lingers. But you begin to realize something else. The problem is not new. It has haunted physics for centuries. Even Newton, who gave us the first clear description of gravity, was unsettled by this. In Newton's universe, gravity acted at a distance, instantly. One object could tug on another no matter how far apart they were, as if space were transparent, as if nothing stood in the way. It was a convenient picture, one that explained the motions of planets and moons, but even Newton admitted it felt wrong. He confessed, in words almost trembling with unease, that the idea of one body influencing another across empty space without any medium, without any messenger, was so great an absurdity that no man who has in philosophical matters a competent faculty of thinking can ever fall into it. And yet Newton's equations worked. They predicted orbits, tides, the fall of apples. They built the scaffolding of modern science. The theory of instant gravity held the universe together on paper. But was it real? You let your mind wander back to that moment in history, the 17th century. Newton at his desk scribbling notes, haunted by the idea that he had uncovered a truth that felt absurd. Did he know as he wrote that centuries later people like you would still be lying awake, turning the same question over and over? Did he sense the incompleteness of his own solution, that gravity still hid its deeper nature behind the veil? And then you remember, centuries after Newton, Einstein would step onto the stage. Einstein, who reimagined gravity not as a force but as the bending of space and time itself. For him, gravity was no longer a rope tugging instantly across distance. It was the geometry of the universe, the curve in the fabric on which planets rolled. But you are not ready for Einstein yet. You are still here in the setup, feeling the tension between what seems immediate and what must be delayed. You are still asking the basic question, if nothing outruns light, how can gravity? The thought grows heavier when you realize what's really at stake. If gravity outruns light, then Einstein's great law is broken. The universe is not bound by one speed limit. Faster than light communication is possible. Cause and effect crumble. The order of events dissolves. But if gravity does not outrun light, if it trudges along at the same pace, then you face the other nightmare. The universe should not hold. The planets should not orbit in harmony. The galaxies should not spin in balance. Everything should lag, tugging toward empty air, chasing where things were rather than where they are. And yet look outside, the stars are steady, the planets move in rhythm, the galaxies whirl in their cosmic spirals. Somehow impossibility has resolved into order. And this, perhaps, is the most haunting part of all. Because it means that neither of your intuitions is right. Gravity is not instant. Gravity is not delayed. It is something else. Something stranger, subtler, woven into the universe in a way that your imagination can barely grasp. But the answer is not yours yet, not tonight. For now you are still standing at the threshold, peering into the unknown, feeling the tension of the paradox without resolution. And perhaps that is enough. Perhaps the real beginning of understanding is not to leap at an answer, but to linger in the question. To let it gnaw at you, to let it stretch the edges of your thought, to sit with the discomfort of not knowing. You breathe and you let that discomfort in. Because it is here, in the gap between intuition and truth, that science begins. And as you drift deeper into that thought, you know that the next step will be harder. It will mean breaking your intuition apart, showing you that what feels obvious, what feels immediate, is not always what is real. For now, though, you lie in the paradox, suspended between two impossibilities, waiting for the crack to widen, waiting for the moment when the world you think you know will fracture and reveal what lies beneath. You've been carrying the question like a stone in your pocket, heavy but silent. Does the speed of light cancel gravity? For 3 steps you've circled it, stared at it, let it breathe. Now comes the part you've been avoiding, the fracture, the break, the moment when your intuition starts to unravel. Because intuition has always lied to you. It lied when you believed the earth was flat. It lied when you thought the sun moved around your world. It lied when you imagined that heavy objects fall faster than light ones. And it is lying to you now, whispering that gravity feels instant, whispering that what you sense must be what is real. So let's break it. You start with something simple. Imagine you are standing on the shore staring out across the sea. You see a boat on the horizon. A wave ripples outward from its hull, moving across the water. That wave is not instant. It travels with speed depending on the depth, the density, the wind. You can watch it approach. You can measure its delay. Now imagine the boat again, but instead of water, imagine it floating in space. It moves, and somehow its pull must also move. Gravity, like that wave, must ripple outward. Why should it be different? Why should it ignore the delay that everything else respects? Your intuition protests, but you remind yourself your senses are slow. You live in a bubble of tiny scales. The delays of gravity, if they exist, are too small for you to feel. Take the glass you dropped earlier. If the Earth's gravity takes time to reach it, say the tiniest fraction of a millisecond, that delay is invisible to you. Your nervous system is sluggish, your perception is crude, you can't measure it without tools. And so your brain tells you it must be instant, but brains are not measuring devices, they are deceivers. The same way the sky deceives you into believing it revolves around the Earth, your daily life deceives you into believing that gravity is immediate. But what if it is? The thought begins to pry open your certainty. You imagine the Earth orbiting the Sun again. If gravity were truly instant, Earth would be pulled toward the Sun's present location. But instant gravity means faster than light signals, which means you could know about events before light arrives. That would break causality itself. If instead gravity moves at the speed of light, then Earth should be pulled toward where the Sun was 8 minutes ago. And if that were true, Earth's orbit should collapse in instability. A delay like that, stretched over billions of years, would turn order into chaos. The solar system should have disintegrated long ago. And yet here you are, stable, alive, orbiting, watching the planets move in their elegant, predictable dance. The conclusion is not obvious, neither picture works, and this is where your intuition fully cracks. Because gravity, as you have been imagining it, isn't real, not in the way you think. It isn't a rope tugging across distance. It isn't a force that leaps from the Sun to Earth like a thrown lasso. It is something stranger, subtler. It is the shape of space itself. But you're not ready for the full revelation yet. First, you must sit in the discomfort of broken intuition. You must feel what it's like to let go of the false comfort of instant. You remember Newton again. He gave you the tools to predict gravity, to describe it, to use it. His laws could tell you where a planet would be tomorrow, next year, in 100 years. But even Newton admitted the mechanism was absurd. Action at a distance with no messenger, no medium, no explanation. It worked, but it haunted him. Your intuition inherited Newton's unease. You still picture invisible strings holding everything in place. You still imagine gravity as a pull, an immediate influence. But what if that picture is as wrong as believing the Sun orbits Earth? What if the truth is stranger than you want it to be? You begin to sense the cracks forming wider. You think of sound again, delayed thunder after lightning. You think of light itself, bound by its speed, incapable of reaching you without time. And you ask, why should gravity escape? Why should it alone be allowed to leap across the void instantly? The answer is simple: it shouldn't. And so you prepare yourself for the turn. If gravity is not instant, if it obeys the same limit as light, then it cannot be what you thought it was. It cannot be a rope, a force, a tug. It must be something deeper. And this is where Einstein begins to loom at the edge of your thoughts, like a shadow waiting in the wings. He will come and he will tear apart your picture of the universe, replacing it with something both terrifying and beautiful. But you are not there yet. You are still in the fracture, in the break. For now, you just hold the contradiction. Gravity cannot be instant. Gravity cannot be late. Both pictures are wrong. And that means you must let go of them. Your intuition resists, but you press deeper. You imagine yourself standing in space, watching two massive objects collide, say, two black holes spiraling into one another. If gravity were instant, the moment they shifted, you would feel it everywhere. The entire universe would know at once, but that cannot be. No signal is faster than light. If gravity were delayed, then the ripple of their collision should crawl outward, late, distorted, pulling on everything from an outdated position. But the universe is not distorted in this way. It remains precise. So what happens instead? The answer waits in the shadows. Gravity ripples. It moves like a wave carried through space-time itself, racing outward not instantly, not late, but exactly at the speed of light. You are not ready to see that yet, but the seed is planted. The fracture has begun. For now, you drift deeper into the brokenness of your own intuition. You sit with the discomfort that what feels obvious is not real, that your senses are liars, that your picture of gravity is a child's drawing compared to the architecture hidden underneath. And in that brokenness, something new stirs, curiosity, a hunger to know what comes next. You breathe and you let the silence of space fill you, knowing that the break is only the beginning, because the real story of gravity is stranger than you can imagine. And now you are ready for it to be told. You've already begun to see the cracks. The comfort of believing gravity is instant has slipped away. The trust in your senses, what you feel, what you see, no longer holds. And yet your mind clings to the illusion. It doesn't want to let go, because instant gravity feels right. It feels natural. Every drop, every fall, every orbit in your imagination depends on it. To let it go is to surrender something deeper than physics. It is to admit that your world is stranger than you want it to be. But tonight you cannot keep it. Tonight you let it break. Think about distance for a moment. Imagine you are speaking to someone on the moon. You say a word and it takes a little more than a second before they hear it. That delay is small, but you notice it. The speed of light, 300,000 kilometers per second, feels infinite to your daily life, but it is not. Even across the Earth, signals hesitate, conversations across continents lag. The internet pauses, distance demands time. Now imagine you are speaking to someone on Mars. The delay stretches into minutes. On Saturn, more than an hour. Across the galaxy, tens of thousands of years. Light is fast, but it is not instant. And then you ask yourself again, if gravity is real, if it is a signal, why should it escape this law? Why should it cheat? Your intuition shouts back, because it feels instant. But then you remind yourself, so did the sun circling the Earth. So did the belief that heavier things fall faster. What feels right has never guaranteed truth. You begin to sense the illusion more clearly. Gravity feels instant not because it is, but because the scales of your life hide the truth from you. The Earth is so massive, so close, so constant that any delay is invisible. You are standing in a room of tricks, blinded by the size of your own stage. And so you must step off the stage. You must think big. You imagine again the solar system. Earth pulled toward the sun, Jupiter pulled toward the sun. Neptune, Pluto, comets all held in orbit. If gravity were truly instant, then each planet would be pulled toward the sun's real, current position, no delay, perfect immediacy. But that cannot be true, because if gravity were faster than light, information could move faster than light. You could detect events before light carried their message. The collapse of causality would follow. Reality itself would bend into paradox. But if gravity moves at the speed of light, then Earth should be pulled toward the sun's old position, 8 minutes behind. And if that were true, the orbit would unravel, drifting into chaos. You feel trapped again, boxed in by two impossibilities. Your mind resists, it demands one or the other, instant or delayed, present or past, but neither fits. This is the heart of broken intuition, realizing that the categories you've been using aren't enough. That reality doesn't care what feels right to you, that your tools are too blunt to cut into the truth. And so you begin to notice what you've been missing, the hidden assumption beneath the paradox. You have been picturing gravity as a force, a rope, a pull across distance. But what if that picture itself is wrong? What if gravity doesn't move at all, not in the way you imagine? This is where the fracture deepens. You remember Newton again. His laws worked. They predicted orbits, tides, planetary motions. But they also carried a ghost inside them, the ghost of action at a distance, a body tugging another without explanation. Newton himself admitted the ghost haunted him, and now it haunts you too. Because when you let yourself imagine gravity as a force, you fall into the trap. You ask whether that force is instant or delayed. You force it into categories it may not belong to. But what if gravity is not a force at all? The thought unsettles you. It rattles the box you've been thinking inside. It whispers that maybe you've been asking the wrong question from the start. Still, your intuition fights back. You think of dropping the glass. You think of falling, of orbiting, of weight. It feels like a force. It feels like a pull. How could it be anything else? But then you think of light again. For centuries, people thought light was instantaneous. They believed it needed no time to move. Why? Because their eyes couldn't detect the lag. They believed what they felt, and they were wrong. Gravity, too, may be playing the same trick. You close your eyes and you imagine again two massive objects in space, two black holes spiraling into one another, collapsing in on themselves. If gravity were a force, their pull would be tangled in paradox, either instant, breaking Einstein, or delayed, unraveling the system. But what if gravity is not a pull at all, but a curve, a distortion, a shape of space itself? Then the paradox dissolves. You're not ready to hold that answer yet, but you feel the edge of it. For now, your task is to live inside the fracture, to let the brokenness of your intuition sting, to admit that what feels obvious is not trustworthy. You take comfort in remembering that this is how science has always worked. Humans believed the Earth was the center. They believed fire was an element. They believed motion required constant force. They believed heavier objects fell faster. Each time the intuition felt secure. Each time it was wrong. Why should gravity be any different? You breathe and you let the tension hang in the air. The silence of your room mirrors the silence of space, vast, unmoving, deceptive. You lie there thinking of the pull you feel, the weight of your own body against the mattress, the tug of the earth beneath you. And you whisper to yourself, maybe this too is not what it seems. The stone in your pocket has cracked, and soon the fragments will reveal something stranger, something far beyond what your senses can offer. But for now, you stay here in the brokenness. You sit with the paradox unresolved. You accept that your intuition has failed you, because only by breaking it can you learn what gravity truly is. And only then will the question finally begin to make sense. Does the speed of light cancel gravity, or does it reveal what gravity really is? The night stretches on, and the question echoes like a distant bell. You are no longer afraid of its weight. You are ready for the fall. The stone in your pocket has cracked. You feel it now sharp against your hand, the weight of a question that can't be smoothed down by comfort. Does the speed of light cancel gravity? The words have stopped being a simple puzzle. They are a fracture line spreading through your imagination, breaking apart everything you thought you knew about how the universe works. And this is what broken intuition feels like. Not a gentle correction, not a neat adjustment, but a rupture. You thought gravity was a force, a rope tugging across distance. You thought it acted instantly because it felt instant. But the more you stare at the contradiction, the more you realize that feeling is not fact. You begin to see it in layers. First layer, the glass in your hand. You drop it and it falls. No delay. But what is no delay? To your nerves, to your brain, to your clumsy human senses, a delay of even a billionth of a second is invisible. Your perception is slow. The illusion of instant gravity is built into your biology. Second layer, the Earth orbiting the Sun. If gravity were instant, the Earth would always be pulled to the Sun's real present position. If gravity were delayed by 8 minutes, Earth would be pulled toward where the Sun used to be. In either case, your intuition fails. The first picture breaks Einstein. The second unravels the solar system. Both collapse. Third layer, the black holes spiraling in space. If gravity were a rope between them, either it must stretch faster than light or it must trail behind, creating chaos. But neither matches what astronomers observe. When black holes merge, the universe shakes, not instantly, not late, but in perfect rhythm. You begin to realize that your picture of gravity, the pull, the tug, the rope, has been a trick of language all along. Newton called it a force because that was the best word available. But words are cages. They trap the imagination. They give you an image that feels right but is wrong. And you start to see the cracks widen. Think about weight. You believe you feel the Earth pulling you downward. That sense is so constant, so absolute that you trust it without question. But in truth, what you feel is not a pull at all, it is a push. The ground pushing against your feet, your chair pressing against your body, the Earth's surface resisting your fall. Gravity itself is silent, invisible, woven into the fabric of space. The sensation you trust most, your own weight, is already a lie. And then you remember, this is how illusions work. They do not announce themselves as false. They blend so completely with your experience that you never think to doubt them. Your intuition about gravity has been an illusion all along. This realization stings, but it also excites you, because it means that the question, does the speed of light cancel gravity, is not just about physics. It is about learning to distrust what feels obvious. It is about peeling back the surface of your own perception and seeing the deeper machinery underneath. You lie there in the dark, letting this sink in. Gravity is not what you thought. And if that is true, then maybe nothing is what you thought. Maybe reality is stranger than you have ever dared to believe. You think again of Newton, haunted by his own theory, admitting that the mechanism of gravity was absurd. He gave the world a formula but not an explanation. He left the door open. And centuries later, Einstein would walk through that door and tell you that gravity is not a force at all. It is the shape of space-time itself. You are almost ready to hear that story, but not yet, not tonight. For now, you must stay in the break, in the silence after the crack, before the new world rushes in. Because to understand Einstein, you must first let go of everything you thought was secure. You close your eyes and imagine yourself drifting in space. No ground, no weight, no pull, just silence and stars. The Earth is below you, the sun ahead, the Milky Way stretched in endless arcs. And you ask yourself, what is holding all of this together? Is it a force leaping across the void? Is it a delay, a lagging signal? Or is it something else entirely, something stranger, something you are not yet ready to name? The question lingers. It hovers at the edge of sleep. And you realize something profound. Maybe the beauty of science is not in the answers at all, but in the breaking of old illusions. Maybe the real wonder is not in solving the puzzle, but in learning that your picture of the world was never complete. You let that thought soften you. Gravity is not what it seems. Your weight is not what it feels like. The universe is not what it looks like. And yet it works, it holds. It sings its silent song whether or not you understand the words. And so you breathe into the paradox, letting it stretch across you like a shadow. The crack in your intuition has become wide enough now. The old picture has shattered. You are ready to move forward, to gather the evidence, to let theory and observation guide you where common sense cannot. But not yet. Tonight you rest in the aftermath of the break. The world you thought you knew has already fallen away. And in the quiet that follows, a new world waits just beyond reach. You've been living in the fracture. The clean certainty of instant gravity has collapsed. The simple picture of a rope tugging across the void is gone. You are floating in the dark, stripped of your old assumptions, waiting for something stronger to appear. And here, in the emptiness, the evidence begins to arrive. You start with the simplest kind, the sky itself. Every night you look upward and what you see is a history book. The stars are old by the time their light reaches you. A star 10 light-years away shows you what it looked like a decade ago. A galaxy 1,000,000 light-years away is 1,000,000 years in the past. The universe is a museum of echoes. Nothing in it reaches you without delay. And you ask, if light takes time, why wouldn't gravity? The evidence whispers it does. But evidence is never one note, it's a choir. And so you listen closer. You imagine again the sun and earth. If gravity were instant, Earth would be pulled toward the sun's real position. If gravity were delayed, Earth should be tugged toward the sun's past position 8 minutes late. Either way, disaster, but in reality, Earth orbits smoothly. Why? Because gravity doesn't point to the past. It doesn't point to where the sun was. It points to where the sun is going. Gravity includes not only position but momentum. The mathematics, Einstein's mathematics, show that the orbit is stable because gravity is not a simple rope. It is geometry, a bending of the path that already anticipates motion. That's the first piece of evidence. The orbits hold, and they hold in a way that only makes sense if gravity travels at the speed of light. woven into the very structure of space-time. You let that sink in. Then another piece arrives, stranger, more dramatic. Black holes, massive, invisible, colliding in the dark. When they merge, they do not simply vanish into silence. They send ripples outward, gravitational waves, like waves on a pond, but in space-time itself. And those ripples move at one speed, and one speed only, the speed of light. You think of the detectors on Earth, giant L-shaped instruments like LIGO, laser beams stretched kilometers long, waiting for the faintest tremor in the universe. And in 2015 they felt it, the shiver of two black holes colliding more than 1 billion light-years away. The signal arrived not instantly, not delayed, but perfectly timed with the light from the event. Gravity moved at light speed, not faster, not slower, exactly the same. This is not intuition. This is not imagination. This is measurement. The evidence sings louder now. You think again of pulsars, dead stars collapsed into spinning cores. Some of them orbit each other, radiating energy. Astronomers measured their dance year after year, decade after decade, and saw them spiraling closer together, losing energy exactly as predicted, by gravitational waves moving at light speed. Not instant, not lagging, perfectly aligned. You feel the pieces stack one by one. Orbits that should unravel remain stable. Hiding black holes send waves that match the predictions. Stars spiral in ways that can only be explained by gravity, carrying energy away at light speed. The illusion of instant gravity grows thinner with every layer. And then beyond the measurements you find the theory itself, Einstein's great leap. He told you that gravity is not a force, it is not a rope, not a tug, not an invisible hand. It is the shape of space-time. Matter bends space. Space tells matter how to move. And if gravity is the bending of space, then of course it cannot leap faster than light, because space itself has rules. Ripples in space-time must move at the cosmic speed limit just as light does. They are not exceptions, they are part of the same fabric. You let that idea settle, though it still feels strange. Gravity isn't a messenger darting between objects. It isn't a signal racing from sun to earth. It is the architecture itself, bending, flexing, shifting. And when that architecture changes, the ripple spreads outward, not instantly, not sluggishly, but at the same speed that light does. For centuries, people argued, they doubted. They asked if gravity was different, if it slipped past the rules. And then, piece by piece, the evidence answered. Light and gravity are not enemies, they are bound together. The speed of light does not cancel gravity, it defines it. It sets the pace at which space itself can stretch, at which the universe can communicate its changes. You breathe, and you let that evidence wash over you. Because it is not only about numbers and equations, it is about a deeper trust that the universe is coherent, that the same rule applies everywhere, from the glass falling from your hand to black holes colliding 1 billion light-years away. That light and gravity share the same limit, the same constraint, the same cosmic leash. And suddenly the question you began with, does the speed of light cancel gravity, feels different. It is no longer a threat, no longer a paradox, but a doorway. The speed of light does not cancel gravity. It defines the way gravity moves, the way space speaks, the way the universe maintains its balance without tearing itself apart. You close your eyes and you imagine the ripples spreading. A star collapsing, sending waves of gravity outward, a black hole merging, shaking the fabric of space, a galaxy spinning, its pull reaching across the void. None of it is instant, none of it is late, all of it bound by the same rhythm, the same cosmic tempo, the same light-speed dance. And you feel something new inside you, relief. The paradox has not destroyed you, it has opened into harmony. The evidence has begun to stack. And yet you know this is only the beginning, because for every answer there are new questions. If gravity is the bending of space, what is space itself? If ripples move at light speed, what carries them? If the universe has a speed limit, what lies beyond it? The evidence comforts you, but it also provokes you. And so you lie there, half drifting, half awake, letting the weight of the facts press against you. Orbits, pulsars, black holes, detectors. Each one another layer of proof, another stone stacked on the growing tower of truth. Gravity is not instant, it is not exempt, it is bound. And yet it is also beautiful. Because what could be more elegant than a universe where even the deepest force of existence obeys the same rhythm as light, the same cosmic speed limit, the same fundamental law? You drift deeper and you know that the evidence will continue to grow. You have only touched the first pieces, more waits ahead, more proof, more wonder. The fracture of intuition is healing now, but healing into a new shape, a stranger shape, one you do not yet fully understand. For tonight, you rest with the evidence. Tomorrow, you will stack more. You are lying in the dark, surrounded by silence, and yet your mind is filled with ripples, gravitational waves spreading, light racing, the cosmic rhythm playing at the one speed the universe allows. The evidence is already strong. You've felt it in the orbits that remain stable. You've seen it in the black holes that collide and send waves at the speed of light. You've traced it in pulsars spiraling closer, losing energy exactly as predicted. But the story doesn't stop there, because gravity, as strange as it is, has left fingerprints everywhere, fingerprints that only make sense if it moves at light speed. You think of one of the most dramatic proofs. The year is 1990. The world is recovering from war. A total solar eclipse stretches across the sky, and astronomers gather with instruments ready, waiting for the moment when the sun's light will be hidden. Why? Because Einstein has made a prediction. If gravity is not a force but the bending of space-time, then light itself should curve as it passes near a massive object. The sun in its bulk should bend the stars around it. Normally you can't see this because the sun's brightness drowns out the stars. But during an eclipse, when the sky goes dark, the stars behind the sun are revealed. And there, in 1919, the measurement is made. The stars appear shifted, bent by the sun's gravity. Light has taken the curved path carved into space-time. Not instantly, not exempt. Light and gravity are woven into the same fabric, and the bending proves it. You picture it now, the sky gone dark, the corona shining, the stars displaced from where they should be. A simple photograph becomes a revelation. Einstein was right. Gravity is not instant, it is not a force in the old sense. It is geometry itself, obeying the same speed limit that binds light. You let that image linger. Then you think of something subtler, gravitational lensing. Imagine a massive galaxy between you and a distant quasar, a beacon shining across billions of years. The galaxy bends space and the quasar's light travels around it. You see not one image, but 2 or 4 or rings of light stretched across the sky. Nature itself becomes a lens. And what does it prove? That gravity bends light not as a force tugging instantly, but as the shape of space evolving at the speed of light. Every arc, every ring, every distorted quasar is another fingerprint. You drift deeper into these images, eclipse photographs, cosmic lenses, ripples in space-time, each one a clue, each one stacking the evidence higher. And then you remember, if gravity truly moved faster than light, these fingerprints would vanish. You would see distortions that arrive before the event, ripples that outpace light, paradoxes everywhere. If gravity moved slower, galaxies would dissolve, orbits would unravel, the universe would tear itself apart. But none of that happens. What happens instead is harmony. Gravity and light share the same speed, the same limit, the same rhythm. It is not coincidence, it is not chance, it is law. You breathe and you let this comfort you. Because what could be more reassuring than a universe where even the deepest mysteries play by the same rules? And yet the evidence keeps piling. You think of the way time itself bends. Clocks near massive objects tick more slowly. Astronauts circling Earth age differently than people on the ground. PS satellites have to correct for relativity, both special and general, or your navigation would drift kilometers away. These corrections work only if gravity obeys the speed of light. If it were instant, the timing would be wrong. The world would not match the calculations. Your phone would fail you, but it doesn't, it works. And every moment it does, it confirms Einstein's law. You think of cosmic delays too. Imagine a neutron star explosion, an event so violent it sends both light and gravitational waves outward. In 2017, astronomers saw it, light and gravity arriving together across 130 million light-years in perfect harmony, not one faster than the other, not one lagging, both obeying the same speed, both reaching Earth as if the universe itself were conducting them in a single symphony. You remember that moment. The newspapers called it multi-messenger astronomy. For the first time, humanity saw an event in both light and gravity at once, and what it revealed was not chaos but coherence. The cosmos is consistent. Gravity and light move together. The evidence has grown into a mountain. Orbits, black holes, pulsars, eclipses, lenses, satellites, neutron stars, all pointing to the same truth. Gravity is not instant, not delayed, but bound at light speed. You lie there, letting the weight of it press against you. It is heavy, but it is also comforting, because what once felt like a paradox has unfolded into clarity. And yet a part of you still resists. A small voice inside still whispers, but it feels instant. When I drop something, I don't feel delay. When I stand on the ground, I don't feel lag. That voice is stubborn. But you remind yourself again, scales deceive. Your life is too small, your senses too slow, your perception too crude. The universe does not exist to match your feelings. It exists on its own terms, and only evidence can reveal those terms. You smile at that thought, even as your eyes grow heavier. The evidence does not care about comfort. It does not care about intuition. It only speaks quietly in eclipses and ripples, in signals arriving across billions of years. And when you listen, you hear the truth. Gravity does not outrun light. It does not lag behind. It is part of the same dance, the same law, the same cosmic choreography. And so, piece by piece, your picture of the universe rebuilds itself. The fracture of intuition is healing into something new, a geometry instead of a rope, a ripple instead of a pull, a law instead of a paradox. You breathe in the dark and you realize you are not done. More evidence waits, more layers, more mysteries. But for now, the stack is already towering. It has carried you from illusion into understanding, from paradox into order. You close your eyes and let it stand there solid, a mountain in the silence of space. And you know, as you drift further, that tomorrow you will climb higher still. The mountain of evidence is already towering. But mountains are not built of single stones. They rise from layers, strata pressed together over time, each one telling part of the story. And gravity, too, has left its layers, subtle, patient, undeniable. You think of the smallest proofs now, the ones hidden not in stars or galaxies, but in clocks, signals, and the quiet machinery of human life. Begin with time itself. You carry a clock with you every day, though you may not think of it. It hides in your phone, in satellites orbiting above, in systems of timing that stretch across the planet. And these clocks tell a truth that feels impossible. Time does not pass at the same rate everywhere. Near a massive object, time slows. A clock on the surface of Earth ticks more slowly than one in orbit. A clock on Jupiter's moons would run slower still, and we know this not because it sounds poetic, but because we measure it. When engineers built the Global Positioning System, GPS, they faced this truth. Satellites orbit high above, moving fast away from Earth's mass. Their clocks tick differently than yours. Without correction, GPS would drift kilometers off every single day. Maps would fail, navigation would collapse, but corrections are made, relativity is honored, and so the system works. And this is evidence, because those corrections only make sense if gravity is not instant, not magical, but bound by the same rules as light. The bending of time is part of the same geometry that carries gravitational waves outward at light speed. You hold your phone and realize, every direction it gives you is proof that gravity obeys the limit of light. That thought alone could keep you awake, staring at the ceiling. The most ordinary tool of your life whispers of cosmic law. But the layers continue. Consider the way astronomers measure pulsars, dead stars spinning with clock-like precision. Some pulsars orbit one another, locked in a binary dance. They lose energy, spiraling closer, radiating gravitational waves into the cosmos. The loss is subtle, barely detectable, but over decades, astronomers have watched it accumulate. They have plotted the spiral, the shrinking orbit, the rhythm of two stars collapsing into one. And every line on the graph matches Einstein's prediction. The waves carry energy away exactly as they should, moving at the speed of light. Not faster, not slower. Decades of patience confirm what intuition denied. You think of those astronomers hunched over data year after year, recording faint pulses of radio waves, trusting that time itself would reveal the truth. And it did. This too is evidence that reality yields to patience, that what feels impossible becomes clear when you wait long enough. And then you think of the boldest evidence of all, the detectors built on Earth to measure gravitational waves directly, giant arms of lasers stretching for kilometers, mirrors so precise they can detect movements smaller than the width of a proton, machines so sensitive they can hear the trembling of the universe. For years they listened to silence. Nothing, only noise, static, the hum of the Earth. But in 2015 the silence broke. A faint ripple, a whisper in the dark. Two black holes colliding a billion light-years away. The signal matched exactly the prediction. The waves moved not instantly, not sluggishly, but at the speed of light. And when light from such events is seen alongside the waves, gamma rays, X-rays, the visible afterglow, they match, arriving together. Different messengers, but one rhythm. You let that image fill your mind. Two messengers leaving a single event, racing across the void for millions of years, arriving at Earth in harmony, as though the universe itself kept time. That is not illusion, that is evidence. You breathe deeper, feeling the weight of it now, because it is not only about black holes or pulsars or GPS, it is about the coherence of reality. If gravity had been instant, the harmony would break. You would see waves that arrived before light, paradoxes where information outran causality. If gravity had been slower, orbits would collapse, galaxies would unravel, time itself would drift into nonsense. But none of that happens. Instead, the universe holds, stable, predictable, bound. And every measurement, from the faint tick of a pulsar to the collapse of black holes, confirms the same truth. Gravity obeys the same speed as light. You find comfort in that, because it means the universe is not arbitrary. It is not chaos disguised as order. It is law, it is rhythm, it is pattern. And yet the evidence is more than reassurance. It is also humbling, because it reminds you how fragile your intuition is, how little your senses reveal. To you, gravity feels instant. To you, light feels instant. To you, the universe feels simple, but evidence tells a deeper story. Your life is too small to reveal the truth. The scales are too vast, the delays too subtle. Without telescopes, detectors, and decades of patience, you would never have known. You would have lived and died believing the illusion. And that is the beauty of evidence. It frees you from the prison of intuition. It whispers truths your senses cannot hold. It tells you that the universe is bigger, stranger, richer than you imagined. You close your eyes and see the stack now. The bending of light during eclipses. The arcs of galaxies turned into cosmic lenses. The spiraling of pulsars losing energy into the void. The trembling of detectors as black holes collide. The correction of satellites that guide your footsteps every day. The harmony of light and gravity arriving together from across millions of years. Each one a stone, each one another layer in the mountain. And the mountain rises so high that the illusion of instant gravity is buried beneath it. Gone, lost in the weight of proof. The evidence is clear. Gravity does not cancel the speed of light. It is shaped by it, bound by it, carried by it. The speed of light does not erase gravity. It defines how gravity moves, how it ripples, how it reveals itself. And as you lie in the dark, you realize that this evidence is not just about physics. It is about trust. Trust that the universe has rules. Trust that those rules can be known. Trust that your mind, fragile as it is, can still reach across the void and grasp something true. You let that trust steady you. And you drift, holding the weight of the mountain in your chest, knowing that the evidence has stacked high, yet sensing that even higher peaks still wait beyond. Because in the next step, the counter-arguments will come, doubts will rise again, and only by meeting them will the mountain stand unshaken. The mountain of evidence is so high now that you can barely see its peak. It towers above you, casting shadows over your old intuitions. What once felt obvious That gravity is instant, that its pull leaps across the void without hesitation, has been buried under layer after layer of proof. And yet, instead of crushing you, the weight of that mountain lifts you, because evidence does not silence wonder, it deepens it. You think again of the chain of clues that has carried you here, the orbits that remain stable despite your fears of delay, the black holes colliding, sending ripples across 1 billion light-years measured on Earth with impossible precision, the pulsars spinning, their dance shrinking exactly as predicted, the sun bending starlight in an eclipse, galaxies distorting light into rings, satellites correcting their clocks to stay true. Each piece points in the same direction. Each one whispers the same truth. Gravity is not instant, not faster, not slower. It is bound, inseparable from the speed of light. And still, you realize, the most beautiful part is not the evidence itself. It is the way such different kinds of evidence converge. Astronomy with its grand distances and collapsing stars, technology with its satellites and clocks in orbit, physics with its equations woven into space-time. Each one could have told a different story. Each one could have fractured into contradiction, but they don't. They all hum in harmony. And that harmony tells you something profound. The universe is consistent. It does not lie in one corner and tell the truth in another. It does not deceive you with black holes while giving you honesty with satellites. It does not split into contradictions. It holds itself together. And in that coherence, you find trust. You think of it almost like music. Imagine listening to a symphony. Each instrument has its own voice, its own timbre, its own rhythm. Alone, it might sound fragile, incomplete, but together they form something greater, something whole. Gravity's evidence is like that. Each experiment, each observation, each measurement is a note. Together they create the song of the cosmos, a song that sings of unity, of light speed, of geometry woven into the fabric of existence. You let yourself listen, and as you do, you remember how far you've come. Not long ago, you were holding onto intuition. You were clutching the illusion of instant gravity, resisting the thought that it could be otherwise. You dropped a glass and trusted your senses. You felt the ground beneath you and trusted your weight. You thought what seemed obvious must be true. But intuition cracked, evidence replaced it, and now you are standing on firmer ground, not because it feels right, but because it is tested, measured, proven. You realize this is the deeper lesson science always teaches. Not to trust what feels right, but to trust what is confirmed again and again from every angle. The stars confirm it, the waves confirm it, the machines confirm it, the smallest devices in your pocket confirm it, all bound by the same truth. And that truth is simple even if it is strange. Gravity is not a rogue force. It does not slip past the universe's rules. It is not an outlaw defying the speed of light. It is part of the fabric, part of the dance, part of the order. You lie there feeling the steadiness of that realization. The paradox that once unsettled you now feels almost soothing. The contradiction has dissolved into pattern. But in that steadiness, you also feel a tremor, because no mountain stands without winds at its peak. No conclusion lives without doubts pressing against it. And so you begin to sense what comes next. The counter-arguments, the challenges, the edge cases where the story is less clear. Already the questions are stirring. If gravity is geometry, then what exactly is space-time made of? If ripples in space move at the speed of light, can they ever be broken, bent, or outpaced? If gravity is not a force, then why does it feel like one? And if all of this is true, why does intuition resist it so fiercely? The evidence stack has carried you far, but no mountain of proof is immune to questions. And maybe that is the point. Because science is not a fortress where evidence walls out doubt. It is a conversation where evidence and doubt wrestle endlessly, refining each other, sharpening each other. So you breathe and you prepare yourself. The evidence has been stacked high, it stands solid. But now you must let the counter case emerge. You must let the critics step onto the stage. You must allow the doubts to rise, to press, to probe, to see if the mountain holds. You imagine the shift as a kind of weather. The sky has been clear, the mountain bright in the sun of evidence. Now clouds begin to gather, winds begin to stir, shadows creep. And yet you are not afraid, because evidence that survives doubt becomes stronger, truth that resists attack becomes deeper. You are ready to let the counter case arrive. But before you do, you rest for a moment longer in the clarity of what you already know. You think again of the neutron-star merger, light and gravity racing across millions of light years, arriving together like twins. You think of the eclipse in 1919, starlight bending just as Einstein said it would. You think of pulsars spiraling into one another, obeying equations written a century before. And you realize, if the story ended here, it would already be beautiful enough. A universe bound by a single speed limit, a cosmos coherent from the smallest satellite to the largest galaxy. Light and gravity moving together, not rivals but companions. But the story does not end here, because every truth in science must be tested and tested again. And so the counter case waits in the wings. For now, though, you let the mountain stand. You breathe in its silence, its solidity, its reassurance. And you drift, knowing that tomorrow the winds of doubt will rise, and you will climb higher still. You've been climbing the mountain of evidence, each step steadier than the last, each stone laid with precision. By now you might feel as if the summit has been reached, that the case is closed. Gravity moves at the speed of light. The paradox has dissolved. The universe is coherent. But then a new wind begins to stir, thin and cold, cutting across the mountain peak. And with it comes the counter case. Because in science, no answer is final. No truth stands unchallenged. And the first voice of doubt is older than Einstein, older than LIGO, older even than Newton. It is the voice of common sense whispering back into your ear. It still feels instant. You cannot escape it. You drop a glass and it falls. You lean too far and you topple. You walk and each step presses weight into the ground without delay. No matter how many experiments you read about, no matter how many equations you trust, your body insists. Gravity feels immediate. That voice will not go away. It is the same voice that tricked humanity for centuries into believing the Earth was at the center, into believing that heavier things fell faster, into believing that light had no speed at all. It is the voice of lived experience, and it is powerful. Science may break illusions, but the illusions never fully die. And then, beyond intuition, there are sharper doubts. Doubts born not of feeling but of logic. If gravity is a ripple in space-time moving at the speed of light, then what is space-time itself? What is this fabric that bends and flexes? If it carries ripples like a medium, then what is it made of? How does it transmit? What keeps it from tearing? Einstein told you gravity is geometry, but geometry is not substance. Geometry does not ripple. Geometry does not carry energy. So how can you trust that this picture is complete? This is the first challenge. Not that Einstein was wrong, but that Einstein may not have been finished. You think of quantum mechanics, the other great pillar of modern physics. Tiny particles dancing in probabilities, their behavior nothing like the smooth curves of relativity. Quantum mechanics insists that forces must be carried by particles, messengers like photons, gluons, W and Z bosons. If that is true, then gravity must have its own messenger, the graviton. But no graviton has ever been found, not in any collider, not in any experiment. So you are left in tension again. Einstein's smooth geometry works on the cosmic scale. Quantum mechanics, particles work on the smallest scale, but they do not agree. They do not speak the same language. And here is the crack. If gravity and light share the same speed because of relativity, then what happens when you try to quantize it? What happens when you ask for a graviton moving through the void? Does it still obey the same rules, or does the picture collapse? The counter case grows sharper. Some physicists whisper, what if gravity does not move at light speed in every context? What if, in certain exotic conditions, it deviates, slightly faster, slightly slower, hidden in scales we cannot yet probe? Others ask, what if our detectors are only sensitive enough to confirm what we already expect? What if the harmony of evidence is a kind of illusion, a selection effect, a story we tell ourselves? And then there are the philosophers who push from another angle. They ask, if gravity is the shape of space, then is it even meaningful to speak of its speed? A shape does not move, a curve does not travel. Maybe the whole question, does the speed of light cancel gravity, is a category mistake, a question built on flawed language. You let those doubts wash over you. They sting, but they are not empty. Because you know every theory in science has been temporary. Newton worked until Einstein replaced him. Einstein works, but quantum mechanics gnaws at the edges. Somewhere beyond, another theory waits, one that will reconcile them both, one that will reveal what space-time truly is. And when that theory comes, the evidence you trust today may become a stepping stone, not the final word. You imagine again the universe, black holes colliding, stars exploding, galaxies spinning. You trust the evidence that says gravity ripples at light speed. But in the back of your mind, you feel the counter case whisper, what if we're still missing something? You remember how often science has been humbled. Once people believed the atom was indivisible. Once they believed the Milky Way was the whole universe. Once they believed the cosmos was static, eternal. Each time evidence arrived that shattered the picture. Each time the mountain had to be rebuilt. Why should gravity be any different? You breathe and you let that humility settle in you. Because it is not weakness to doubt, it is strength. The mountain of evidence is not a monument to certainty, but to survival, proof that ideas have been tested, attacked, and endured. And yet, you know, some of today's evidence may not survive tomorrow. Maybe gravitational waves hide secrets we have not yet seen. Maybe the quantum world will demand a correction. Maybe a graviton will be discovered, and with it a deeper law, one that reshapes your picture yet again. The counter case does not erase the evidence, it sharpens it. It forces you to ask harder questions, to admit that science is not a cathedral of unchanging truths, but a river, flowing, eroding, reshaping its banks. And you find yourself strangely comforted by this. Because if gravity had been left untouched, unquestioned, wrapped in the illusion of instant force forever, you would still be in the dark. It was doubt that pushed Newton to confess unease. It was doubt that pushed Einstein to rebuild gravity entirely. And it will be doubt that carries the next mind beyond Einstein. So you lie there in the half-silence, with the wind of counter-arguments stirring around you. You are not shaken, you are not afraid, because the story of science is not one of perfect answers. It is one of broken intuitions, stacked evidence, and counter cases that keep the story alive. And this story is not done. Tomorrow more doubts will come, they will cut deeper, they will ask harder questions, they will test the mountain you have built. And when the mountain holds, it will be stronger. But for now, you let the first chill of counter case settle on you like night air. And you close your eyes, knowing the climb is only halfway through. The doubts have begun to whisper, and now they grow louder. You feel them circling, like wind shifting on the slopes of the mountain. They do not topple what you have built, but they press against it, testing its strength, asking whether the foundation is as solid as you believe. And you know this is necessary, because evidence without doubt becomes dogma. And science is not dogma, it is survival, it is resilience, it is the willingness to question even the things you think you know. So you let the counter case speak. One of the first voices belongs to the family of alternative gravities. Theories that say, perhaps Einstein's picture is not the whole story. Perhaps gravity does not always behave exactly as general relativity predicts. You think of MOND, modified Newtonian dynamics, a strange name for a strange idea. It began as a whisper in the late 20th century when astronomers noticed that galaxies were spinning too fast. Their outer stars should have flown away, flung out into the void by centrifugal force, but they didn't. The galaxies held together. The mainstream answer was dark matter, an invisible substance outweighing the visible universe whose gravity held everything in place. But some physicists asked a different question. What if gravity itself behaves differently on these scales? What if Newton and Einstein are only approximations, and in the deep edges of galaxies, gravity bends into a new law? In such models, gravity might not be tied so cleanly to the speed of light. It might have hidden behaviors, hidden shortcuts, cracks in the pattern. Most physicists still favor dark matter. The evidence leans heavily that way. But the very existence of alternative models is a reminder. Even the best theories can be challenged. Even Einstein is not sacred. And then you think of something bolder. What if gravity can move faster than light? You remember those voices, scattered in the history of physics, who argued that perhaps Einstein was wrong about the ultimate limit, that maybe gravity, unlike every other phenomenon, can slip ahead. In the 1990s, some experiments with pulsar timings even seemed to suggest it. Not proof, not consensus, but whispers that perhaps the signals of gravity arrive ever so slightly earlier than light. Later analyses ruled it out, but the whispers lingered, like ghosts at the edge of certainty. And some philosophers still ask, if gravity is the shape of space, then perhaps the question of its speed is meaningless. Perhaps we are asking about something that doesn't move at all but simply is. And if that is true, then all of this talk of speeds and delays may be shadows on the wall, distractions from a deeper reality we cannot yet touch. The counter case cuts deeper when you bring in quantum mechanics. Einstein's relativity says gravity is geometry, smooth, continuous, a fabric bent by matter, but quantum mechanics insists the world is not smooth at all. It is discrete, quantized, chopped into probabilities and packets. If the two pillars are to meet, then gravity must be quantized too. And that means there must be a particle, the graviton, a messenger particle, just as photons carry electromagnetism. But no graviton has ever been detected, not in colliders, not in cosmic rays, not in the faint tremors of detectors. And here is where the counter case digs in. How can you be sure gravity is bound by the speed of light if you have never seen the particle that should carry it? How can you be certain the smooth picture is complete when you have not yet unified it with the quantum? Some physicists dream of string theory, where gravity emerges from vibrating strings and gravitons are inevitable. Others dream of loop quantum gravity, where spacetime itself is woven into tiny loops, a fabric at its smallest scale. Each theory insists the picture you have now is incomplete. Each theory hints that new evidence may one day rewrite the rules. And then there are the boldest speculations, the places where the counter case leaps beyond physics into almost myth. What if there are hidden dimensions, curled up beyond your perception, where gravity leaks and travels differently? What if gravity appears weak in your universe because it spreads across more dimensions than you can see? In such models, its behavior may not be fully chained to the speed of light. What if there are wormholes, shortcuts through space-time, where gravity seems to leap ahead of light, not because it breaks the rule, but because it bends the path? What if the universe itself is only an approximation, a simulation, a code, and gravity is not a real force at all but an emergent property? An illusion like temperature, a byproduct of deeper mechanics you cannot yet grasp. You let those thoughts swirl around you. Some are fragile, some are speculative, some may never be proven, but all of them serve the same purpose, to remind you that no picture is final, that even the mountain of evidence you have built must be ready for the winds of doubt. And in that reminder, you feel something shift inside you. You are no longer clinging to certainty. You are no longer desperate for a final answer. Instead, you are breathing with the rhythm of science itself, evidence, doubt, refinement, survival. You close your eyes and imagine gravity again, not as a rope, not as a ripple, not even as geometry, but as a mystery still unfolding. You imagine Einstein writing his equations not as commandments, but as stepping stones across a river he could not yet see the other side of. And you realize you are standing on those same stones. The water rushes around you, the far shore is hidden, and the only way forward is to keep stepping, to let doubt and evidence guide you together. The counter case is not an enemy, it is a companion. It whispers maybe gravity is different at galactic scales, maybe it leaks into hidden dimensions, maybe gravitons will rewrite the story, maybe speed itself is not the right question. And as it whispers, you feel no fear, only awe. Because the true beauty of science is not in the answers it gives, but in the questions it keeps alive. You breathe, and you let those questions settle in you like seeds. The mountain of evidence stands, but around it the winds of countercase swirl. Together they make the picture real, alive, unfinished, and you drift, knowing that tomorrow more doubts will rise, and with them new ways to see. You have let the countercase whisper to you. It has pointed to quantum mechanics, to hidden dimensions, to speculative shortcuts. It has shaken your trust, not by erasing the evidence, but by reminding you that no evidence is ever final. But doubts do not always arrive in the abstract. Sometimes they come in the form of data, raw, stubborn, inconvenient. History is full of these moments. You think back to the years after Einstein published his general theory of relativity. The equations were bold, the predictions radical. Light should bend, time should slow, space itself should ripple. But for many, the theory felt fragile, even absurd. In the decades that followed, experimenters hunted for cracks, and sometimes they thought they found them. Consider the speed of gravity itself. Even after the eclipse of 1919 confirmed that light bends, questions lingered. Could Einstein really be right that gravitational changes move at light speed? For decades, no one could prove it. Astronomers searched for delays, distortions, signs that orbits should wobble if gravity lagged. Some measurements hinted at anomalies. At times, the orbits of planets seemed to disagree with predictions. Mercury's orbit had been the most famous, its slow precession unexplained by Newton but beautifully resolved by Einstein. But other hints emerged in Jupiter, Saturn, Uranus, tiny discrepancies that seemed to whisper, maybe relativity isn't enough. Maybe the old intuition is right after all. Most of those whispers faded as data improved, errors were corrected, observations sharpened. What once looked like cracks became confirmations, but in their time those anomalies were fuel for doubt. Then there were the binary pulsars. When they were discovered, their spiraling orbits gave physicists the best test yet of gravitational waves. But the first measurement seemed almost too perfect. So perfect that skeptics wondered if astronomers were unconsciously shaping their data, trimming away the noise to fit Einstein's equations. Could the match between prediction and reality be real, or was it the human tendency to see what we want to see? Over time, the measurements endured, the skepticism faded, but the shadow of that doubt lingers in the history of science, a reminder that even the purest evidence must be tested against bias. And then came the gravitational wave detectors themselves, LIGO, Virgo. When the first detection was announced in 2016, not everyone celebrated. Some whispered of noise, of seismic interference, of software errors dressed up as cosmic events. Was the universe really trembling, or had the instruments been fooled? It took multiple detections from different observatories to silence that doubt. Only when black holes merged again and again, when neutron stars collided and light and gravity arrived in tandem, did the whispers begin to fade. But even now some fringe voices remain. They ask, what if LIGO is not hearing space itself but artifacts of the Earth? What if the data is misinterpreted? You may not believe those voices, but you hear them. And they remind you, evidence is never sacred, it is always vulnerable. Beyond experiment, history is rich with theories that once challenged Einstein directly. In the mid-20th century, some physicists proposed superluminal gravity, a model where gravitational effects could propagate faster than light. For them, it solved the problem of stable orbits without delay. For decades, these ideas floated at the edges, never quite disproven, never quite accepted. Only with modern detectors did they finally collapse. Others offered tired light theories, suggesting that the bending and redshifting of light could be explained without relativity at all. For a time, these models carried weight, especially as astronomers struggled to explain cosmic expansion. Eventually, they were ruled out, but the doubt they seeded lived for decades. And even now, alternative models exist. Emergent gravity, entropic gravity, quantum loop cosmology. Each one suggests that perhaps what you call gravity is not a fundamental force at all, but a side effect of something deeper. If that is true, then all the talk of speed, light speed, instant speed, faster than light, may be the wrong conversation entirely. You let these counter cases settle in you, not as threats but as reminders, because this is the rhythm of science. First comes the intuition, simple but misleading. Then comes the break, the paradox. Then the mountain of evidence, proof upon proof. And then always the counter case, doubts, alternatives, anomalies. The mountain is never safe, it is never finished. You close your eyes and imagine yourself as one of those astronomers a century ago, staring at data that doesn't quite fit, torn between belief and suspicion. You imagine being at LIGO, staring at the faint tremor on the screen, wondering, is this the universe or just the earth beneath my feet? And you realize doubt is not an enemy, it is the heartbeat of discovery. Without doubt, no one would have challenged Newton. Without doubt, Einstein would never have been heard. Without doubt, you would still believe in instant gravity, trapped by intuition, blind to evidence. You breathe into that thought, and you let yourself feel the fragility of knowledge. Every theory, no matter how strong, is a raft on the river. It carries you forward. It holds for a while, but the river keeps moving. The raft will one day be replaced. Relativity, too, will yield, not because it is wrong, but because it is incomplete. Somewhere in the cracks between geometry and quantum, a new picture waits. And so, the counter case is not a warning that you should stop believing. It is an invitation to keep questioning. Does the speed of light cancel gravity? The evidence says no, gravity is bound to light speed. But the counter case whispers, maybe the question itself will one day dissolve. Maybe speed is not the right frame. Maybe gravity is not what you think it is at all. You let that whisper echo in you. It does not erase the mountain of evidence, but it reminds you that the mountain is not the horizon. There are higher peaks still hidden in the clouds. For now, you drift in the space between trust and doubt, between evidence and critique, between the comfort of Einstein and the possibility of something beyond him. This is where science lives, not in certainty but in tension, not in final answers but in the questions that refuse to stay quiet. And as you sink deeper into that thought, you feel it again, the paradox, the fracture, the whisper, not as fear this time but as wonder. Because the universe is not fragile for having doubts, it is alive. And tomorrow you will walk further into that aliveness. You will follow the counter case deeper, letting it test what you know until the story bends once again. For tonight, you rest in the knowledge that even the strongest mountains must face the wind. And the wind is still blowing. The wind is stronger now. It howls across the mountain of evidence, pulling at the edges, tearing at the seams. And you let it, because this is what doubt does. It strips you of false shelter, exposes you to the rawness of what you don't yet understand. And nowhere is that rawness sharper than at the edge of a black hole. You close your eyes and imagine one. A star collapsed, its core crushed into a singularity, gravity so strong that light itself cannot escape. The horizon forms, the event horizon, the boundary where escape becomes impossible. On one side, space and time still exist. On the other, they collapse into mystery. Now ask, what happens to the speed of gravity here? If nothing outruns light, then gravity too should be trapped. But if gravity is the very shape of space-time, how can the shape itself be trapped inside the horizon? How can the thing that defines the boundary also obey it? It feels like a paradox nested within a paradox. You imagine a black hole orbiting another star. From the outside, you can still feel its pull. But if nothing escapes, not even light, then how do you feel it? What carries that information out? Does gravity leak past the horizon, disobeying its own rule? Or is the pull not carried outward at all, but simply written into the fabric itself, an imprint that doesn't move but simply is? This is the counter case at its sharpest, the places where words like speed and signal begin to dissolve. And then even stranger, black holes can merge. Their horizons collide, their singularities spiral into one. Gravitational waves ripple outward, carrying the story of their union. But those waves are not born inside the horizon, they are born in the warping space around it, the region just outside the edge. The horizon hides the singularity, but the ripples of its motion escape, moving at the speed of light. Still, the question lingers. If gravity is a ripple in space-time, then does it stop at the horizon? Or does the horizon itself move, carrying the ripple with it? The answers are not clean. Even physicists confess uncertainty here. Black holes are laboratories of doubt. They do not break Einstein's theory, but they stretch it until it groans. And then you move further back to the beginning of everything. The early universe, inflation. In those first instants, space itself expanded faster than the speed of light. Not matter, not signals, but space. Galaxies were pulled apart faster than any information could catch up. The horizon of the visible universe was set. What does this mean for gravity? If space itself can grow faster than light, then does gravity ride that growth? Does it stretch instantly across new regions, or does it crawl forward, bound like everything else? Scientists still debate it. Models predict gravitational waves frozen into the fabric of the cosmos, echoes of the universe's birth. If they exist, they would confirm that even in the fastest expansion, gravity moved at the cosmic speed limit. But so far, the signals remain hidden, buried in noise. Again, the doubt lingers. And then there are wormholes, hypothetical bridges through space-time, shortcuts connecting distant points. If such passages exist, what would gravity do across them? Would it follow the shortcut, appearing faster than light, or would it still be bound by the outer geometry? Speculation swirls here. Some argue gravity could leak, taking advantage of hidden paths. Others insist the rules would still hold, that even in the strangest topologies, the speed of light remains unbroken. And then the most audacious question of all. What if gravity isn't a force, isn't a ripple, isn't even geometry, but an emergent phenomenon? Some physicists whisper of entropic gravity, the idea that gravity is not fundamental but a byproduct of deeper statistical laws. If that is true, then perhaps speed is the wrong language entirely. You cannot ask how fast an illusion moves. You can only ask how it emerges. The counter-case grows dizzying. At every extreme, black holes, inflation, wormholes, emergence, the picture blurs. The speed of gravity is clear in experiments, but what lies beneath those experiments may be stranger than speed, stranger than force, stranger than space-time itself. You lie with this dizziness, letting it wash over you. Because this is the truth of the counter-case, it does not erase the evidence. It unsettles the framework around it. It does not deny the measurement, it questions the meaning. The measurements say gravity moves at the speed of light. That is solid, tested, confirmed. But what it means, what gravity really is, what speed really describes, that remains unsettled. And so you breathe into that tension. You imagine standing at the edge of a black hole, watching the horizon shimmer. You imagine the early universe, space ballooning faster than light. You imagine wormholes twisting shortcuts across the cosmos. You imagine gravity not as a rope or ripple, but as heat, as entropy, as illusion. Each vision pulls at you. Each one reminds you that science is not a finished book, but a manuscript, full of notes in the margins, full of pages still unwritten. And in that unfinishedness, you find beauty. Because if the answers were final, there would be nothing left to ask, nothing left to wonder, nothing left to dream about as you drift towards sleep. The counter-case has carried you far now. It has pulled you through the doubts of intuition, through the challenges of anomalies, through the strangeness of extremes. It has shown you that even the strongest mountains must bend beneath the wind. And now, as the wind dies down, you feel ready to turn again, to move from critique back into synthesis, to gather what is broken and what is proven, what is doubt and what is law, and weave them into a larger vision. But not yet. For tonight, you rest in the quiet after the storm. The evidence stands, the doubts swirl, and you lie between them suspended, waiting for the next step. Tomorrow, the synthesis will begin, and with it, a new shape of the universe will unfold. You've wandered through the storm. You felt the fracture of intuition, the stacking of evidence, the winds of doubt tearing at the edges. And now, at last, the air begins to still. This is the moment of synthesis. It does not come with a final answer, not with a neat conclusion or a triumphant declaration. It comes like dawn, slow, quiet, unannounced, a soft light that reveals how the shadows and the stone, the winds and the mountain, were always part of the same landscape. You begin to see that the question itself, does the speed of light cancel gravity, has carried you in a circle. At first it was a threat. If gravity must obey light's speed, perhaps it would unravel the universe. If gravity were instant, perhaps it would unravel causality. You felt trapped, caught between two impossible choices. But the journey has shown you something subtler. The speed of light does not cancel gravity, it defines it. Because gravity is not a rope flung across the void. It is not a signal darting between bodies. It is the curvature of space-time itself, and when that curvature changes, the ripple spreads outward, not instantly, not sluggishly, but at the same pace that light itself races through the dark. You pause and let that sink in. The speed of light is not an obstacle. It is the rhythm of the universe. It is the limit that holds everything together, the tempo by which both light and gravity play their song. And now you see why the paradox dissolved. The Earth is not tugged toward where the sun was 8 minutes ago, nor is it tugged instantaneously toward where the sun is now. Instead, the geometry of space-time is already shaped by the sun's motion, its momentum, its path. The Earth follows that curve, not a delayed shadow. Stability is preserved, not in spite of the speed of light, but because of it. What once felt like a contradiction was only the shadow of a deeper law. You think back to the evidence, pulsars spiraling in perfect accord with Einstein's equations, black holes colliding, their waves racing outward at light speed, stars bending the light of others in an eclipse, the geometry revealed, satellites adjusting their clocks, obeying relativity every second. Each one seemed like a separate proof, a separate voice. But now in the synthesis they merge, they are not fragments, they are a single harmony, a single architecture. And then you think of the counter case, the doubts, the whispers. At first they felt like threats, they questioned the mountain, they unsettled the ground beneath you, but now you see their role too. The counter case was never meant to topple the truth, it was meant to deepen it, to remind you that science is not finished, that every answer is provisional, that humility is the only true posture toward the cosmos. Doubt does not cancel knowledge, it sharpens it. You feel that clarity now. The fracture, the evidence, the counter case, they were not separate stages. They were necessary steps in a single path. Without the fracture, you would still cling to illusions. Without the evidence, you would drift in confusion. Without the counter case, you would mistake certainty for finality. Together, they carry you here to synthesis. And what is the synthesis? It is the understanding that gravity is not instant and not exempt. It is bound to the same law as light. But more than that, it is the recognition that the law itself, the speed of light, is not a barrier, not a cancelling force, but the thread that weaves the cosmos into coherence. You breathe, and the thought softens into something almost spiritual. Because in this light, the universe does not appear as a battlefield of competing forces, of paradoxes and cracks. It appears as a single story. Light and gravity, not rivals but partners. Geometry and causality, not enemies but companions. Doubt and evidence, not contradictions but complements. And perhaps this is what you were searching for all along. Not an answer to the riddle, but a way to see the riddle itself as part of the beauty. You lie there in the dark, and the synthesis begins to take shape around you like a cathedral. At its base, the foundation of evidence, the detectors, the satellites, the eclipses, the pulsars, stones stacked with care. Above that, the arches of doubt, the counter cases, the anomalies, the whispers of quantum and hidden dimensions. They do not collapse the structure, they frame it, they give it height. And above that, the roof of synthesis, the realization that all of it together is the way science breathes, broken intuition, stacked evidence, pressing doubt, emerging clarity. You are not standing on ruins, you are standing in a living architecture, and you feel a strange gratitude. Gratitude for the intuition that deceived you, because without it you would not have known the joy of breaking it. Gratitude for the evidence that grounded you, because without it you would have floated in confusion. Gratitude for the doubt that unsettled you, because without it you would have mistaken knowledge for finality. You let that gratitude wash through you. And now when you return to the question, does the speed of light cancel gravity? You hear it differently. It is no longer a trap. It is a koan, a paradoxical phrase that opens your mind not by resolving but by transforming. The speed of light does not cancel gravity. It shapes it, binds it, reveals it. And in turn, gravity shows you that the speed of light is not just a number, not just a limit, but a principle, a rhythm, a law that holds the cosmos in balance. You breathe again, slower now. The synthesis is not an ending. It is a way of living with the question. And as you drift closer to sleep, you feel the paradox soften into wonder. Not a problem to be solved, but a mystery to be carried. Tomorrow more will be said, more will be tested, more will be doubted. But tonight you rest in the quiet harmony of synthesis. The universe holds, light and gravity move together, and you, small and fragile, are allowed to glimpse that harmony, if only for a moment. The harmony begins to deepen. You are no longer asking whether light cancels gravity, no longer circling the paradox of instant or delayed. You are beginning to see that the two were never enemies at all. They are threads of the same fabric, inseparable, interwoven. And when you let yourself sit with that realization, a new question emerges. What does it mean for you to live in such a universe? Because this is not just about stars and black holes, not just about equations and detectors. This is about the shape of your own life, the way you experience time, the way you trust cause and effect, the way you understand what it means to exist. Begin with time. In the old picture, time was absolute. It ticked evenly everywhere like a universal clock tower ringing across the cosmos. In such a world, it made sense to imagine forces acting instantly, stretching across space without hesitation. But Einstein's synthesis shattered that comfort. Time is not absolute. It bends with gravity, it slows near mass, it shifts with speed. And because time is elastic, so too are the events it measures. Cause and effect are no longer guaranteed by a universal ticking clock. They are guaranteed by something subtler, the speed of light. That speed is not just a number, 300,000 kilometers per second. It is the boundary that protects causality itself. It is the reason you can trust that causes precede effects, that signals cannot arrive before they are sent, that the universe does not collapse into paradox. In this light, the speed of gravity is not a curiosity. It is the very guardian of order. You lie with that thought, and it feels almost personal. Every second of your life, every breath you take, every moment of memory and anticipation is shaped by the same law that binds galaxies together. And then you think of distance. You are always looking into the past. The sun you see is 8 minutes gone. The stars are centuries, millennia, millions of years behind. Even the moonlight on the ocean is more than a second late. At first, this seems like a flaw, a weakness, an imperfection. Why can't you see things as they are? Why must the universe always reach you second-hand? But now you realize this delay is not imperfection, it is protection. The speed of light and gravity bound with it creates the fabric of your experience. Without it, the universe would unravel. With it, there is coherence, order, rhythm. What feels like distance is really trust. You close your eyes and you imagine the rhythm itself, light racing, gravity rippling, both keeping pace, neither outrunning the other. A cosmic duet, a law not of cancellation but of companionship. And in that duet, you begin to glimpse something even stranger. Because if gravity is geometry, and if that geometry bends time, then you yourself are not separate from this law. You are inside it. Every step you take is written into curved space-time. Every thought you have is bound by the same light-speed limit. You are not outside the fabric observing it. You are part of the fabric itself. And here, the synthesis becomes almost humbling. You are not asking whether gravity is instant, whether light is faster. You are realizing that you live inside a universe where such comparisons are meaningless. Gravity and light are not rivals. They are the structure in which your life unfolds. You think again of black holes, the places where this structure is stretched to breaking. At the horizon, light cannot escape. Time slows to a crawl, and yet the harmony of light speed and gravity still holds, still defines the boundary. Even at the edge of collapse, the duet remains. And you think of the early universe, space expanding faster than light, carrying galaxies apart. Even there, the law did not break. Light and gravity both rode the expansion, woven into the same ballooning fabric. Everywhere you look, at the vast, at the tiny, at the ordinary, the same principle hums. The synthesis whispers, the universe is coherent. You lie with that whisper, and you realize it changes more than physics. It changes philosophy. Because if the universe is coherent, then doubt is not a threat but a feature. It is coherence that allows you to test, to measure, to challenge, and to know that reality will not collapse under pressure. It may surprise you, it may humble you, but it will not betray itself. In a way, the speed of light has always been more than speed. It has been trust. Trust that signals cannot cheat. Trust that events unfold in order. Trust that gravity and light are companions, not rivals. And so, when you return again to the question, does the speed of light cancel gravity? You feel it dissolve in your hands. It was the wrong framing all along. It was never about cancellation. It was about revelation. The speed of light reveals what gravity truly is. Not a force leaping instantly across space, not a lagging signal chasing after the past, but a geometry, a fabric, a rhythm that holds everything together. And in that revelation, you feel the paradox soften into beauty. The universe is stranger than you thought, but it is also steadier. The very law that bends light is the same that shapes gravity. The very speed that limits you is the same that preserves order. You breathe and you let this sink in. The synthesis is not a neat answer. It does not erase the doubts. It does not solve the mysteries of quantum gravity or the whispers of hidden dimensions or the riddles of black holes, but it gives you a way to live with. It tells you that gravity and light, doubt and evidence, illusion and truth are not separate chapters. They are one story unfolding together. You let that story hold you now like gravity itself. Not instant, not delayed, simply present, steady, unbroken. And as your eyes grow heavier, you feel a quiet gratitude. Gratitude that the universe is not chaos. Gratitude that even in its strangeness, it holds coherence. Gratitude that you are here, small but conscious, allowed to glimpse the pattern for just a moment. The synthesis is not the end. It is the deep breath before the next question. But tonight, that breath is enough. You let the harmony settle in you. You let the rhythm of light and gravity carry you. And you drift, suspended in the fabric, part of the duet. The universe holds. The synthesis holds you now like a quiet hum. You are no longer trapped by the paradox of instant versus delayed. You are no longer tossed between the mountain of evidence and the storm of doubt. You are resting in something wider, softer, more complete. And it begins to change the way you see everything. You look at the sky differently. Before, when you looked at the stars, you might have seen distant points of light, curiosities scattered across the black. Now you see a web. You see light crossing the void at the same speed as gravity's ripples. You see coherence written into every star, every galaxy. And you realize you are not outside this web observing it. You are inside it. Every step you take, every breath you draw is woven into the same geometry. You think of time again, the way clocks run differently depending on where they are. The way gravity bends not just space but duration. You remember that GPS satellites have to account for relativity or they would fail. You remember that black holes stretch time to near infinity. And you feel it, you are not living in a neutral arena. You are living in a fabric that flexes beneath you. Every moment of your life is written into that bending. This is the first truth of synthesis. You belong to the fabric, not apart from it, not above it, inside it. And then you think of order. For so long you wondered, if gravity is not instant, how can the universe hold together? Wouldn't everything drift, unravel, collapse into chaos? But now you see that the speed of light itself is what preserves order. It is not a limitation, but a principle of coherence. If signals could outrun light, the universe would collapse into paradox. If gravity lagged behind, galaxies would dissolve. The very thing that felt like a threat, the speed limit, is what allows reality to exist at all. This is the second truth of synthesis. The limit is the gift. You close your eyes and let that idea soften you, because in your own life, limits often feel cruel. The limit of your time, the limit of your body, the limit of your knowledge. You want to outrun them, you want to cheat, but maybe, just as in physics, limits are not enemies. Maybe they are the structure that makes meaning possible. Without limits, there is no story, no sequence, no cause and effect. The speed of light is not only a cosmic rule, it is a metaphor for the way life itself holds coherence. This is the third truth of synthesis. The cosmos and your life rhyme. You think of gravity not just as a scientific fact, but as a teacher. It shows you that what feels instant is not, that what feels obvious is not the truth, that you must let go of illusions to see deeper. And it shows you that doubt is not weakness but strength, the very thing that drives discovery. And then the most profound lesson. Gravity shows you that you are not separate from the universe. You are not a spectator. You are part of the geometry, part of the rhythm, part of the duet of light and gravity. The question that haunted you at first, does the speed of light cancel gravity, was never just about physics, it was about belonging. You worried the universe might not hold, that stability might fracture. You feared a contradiction so deep that it would break the cosmos itself. But now you see, the universe holds, it is coherent, and you are inside that coherence. You breathe more slowly now, as if your lungs were moving in time with the fabric itself. And as you drift deeper into this thought, your mind wanders to the great paradox of perspective. From one angle you are tiny, a single body on a single planet, drifting around a single star in a galaxy among billions. What could your life matter against such immensity? But from another angle you are vast. You are made of the same particles that curve space, the same matter that bends time. The rules that govern galaxies also govern you. When you move, you bend the fabric. When you live, you echo the same principles that hold the cosmos together. The synthesis is not just about science, it is about identity. And you feel the shift. You are no longer asking physics for certainty. You are listening to it as if it were poetry. You are letting it teach you not only how the universe works, but how to live inside it. This is the fourth truth of synthesis. Science is not separate from meaning. You let that truth rest in you. You imagine again the black holes, their ripples racing outward at light speed. You imagine galaxies spinning, held in coherence. You imagine the first seconds of the universe, inflation carrying space faster than light but never breaking the law, only stretching it. And then you imagine yourself lying here, bound by the same fabric. Light racing from your phone, gravity holding you to Earth, both moving at the same speed, both keeping the order of your world intact. You are not apart from the story, you are inside it. And the synthesis tells you that is enough. The universe holds you, not in spite of its strangeness, but because of it. The paradox you feared was never a danger, it was a doorway. The question you asked was never a trap, it was a gift. And now, as your eyes grow heavy, you realize, the question does not need to be answered once and for all. It needs to be lived with, it needs to be carried. It needs to echo in you like the hum of the fabric itself. And so, you let it echo. Does the speed of light cancel gravity? And you smile at the echo because you know now, the speed of light does not cancel gravity, it completes it. It makes the universe whole. It makes your life possible. And it makes every question you ask another thread in the same fabric. You drift deeper into that thought, the synthesis unfolding not as resolution but as harmony. You are small, you are vast, you are held. The universe bends, but it does not break. And you, too, belong to that bend. You've walked the long arc of the question. From the first moment when you asked if the speed of light cancels gravity, through the fracture of your intuition, through the building of evidence, through the winds of doubt, and now here in the stillness of synthesis. And in this stillness, you see the universe differently. It is no longer a puzzle of competing forces, no longer a contradiction between instant and delayed, no longer a battlefield where gravity and light fight for supremacy. It is a tapestry. Light and gravity are not rivals, they are threads interwoven. The speed of light is not a wall that cancels gravity, it is the loom on which gravity is woven. The universe is not fractured by paradox, it is bound by rhythm. And that rhythm has been speaking to you all along. When you watched lightning and waited for thunder, you were seeing delay. When you looked at stars, you were seeing the past. When you dropped a glass, you thought you were seeing instant pull, but you were only blinded by scale. And when astronomers measured ripples, bends, shifts in starlight, collapses of neutron stars, tremors of black holes, they were all hearing the same rhythm, light and gravity moving together. You breathe in the quiet of that recognition. The paradox has dissolved not by choosing one side, but by showing you a larger truth. The categories themselves were too small. Instant or delayed, present or past. Those words could not capture what gravity truly is. Gravity is not a signal chasing after mass. It is not an invisible rope snapping taut. It is the shape of the fabric itself, bending in time with the same law that governs light. The synthesis is not a tidy equation, it is a way of seeing. You imagine yourself standing outside on a still night, the stars stretched overhead. Once you would have thought you were watching a sky of points, simple lights on a backdrop. Now you know you are looking into a woven fabric, alive with tension and coherence. The stars you see are echoes, their gravity and light arriving together across impossible distances, bound by the same tempo. The night sky is not chaos, it is order, it is not contradiction, it is rhythm. And in that rhythm, you find something like peace. Because if the cosmos is coherent, then you too are coherent within it. If the speed of light protects causality across galaxies, then it protects causality in your life too. If gravity and light move together in harmony, then you too are part of that harmony. You pause and let that sink in. The speed of light is not just a limit, it is a promise. It promises that the universe will not betray itself with paradox. It promises that the laws that hold in one corner will hold in another. It promises that gravity is not cancelled, not erased, but carried faithfully in the same rhythm as light. And you realize something subtle. The beauty of science is not in its answers alone, but in the way those answers mirror your own existence. You live with illusions, you trust intuition, and then when those illusions break, you feel lost. But if you wait, if you stack evidence, if you allow doubt, you eventually find synthesis. You find that the paradox was not a wall but a doorway. The story of gravity is the story of you. A broken intuition, a stacked evidence, a counter case, a synthesis. That is how you learn, that is how you live, that is how you grow. And so as you lie in the dark, you feel a strange comfort. The universe is vast, strange, and often incomprehensible. But its strangeness is not disorder, it is depth. Its mysteries are not chaos, they are invitation. You think of Einstein scribbling in his notebooks, seeing beyond Newton's ropes to a geometry that no one else had dared imagine. You think of the astronomers waiting under the eclipse in 1919, staring at stars bent by the sun's gravity. You think of the scientists listening to LIGO's faint tremors, hearing the universe whisper across billions of years. They were not chasing certainty, they were listening for coherence, and they found it. And now you feel it too. The speed of light does not cancel gravity, it completes it, it binds it, it makes it visible. You pause and repeat that to yourself softly, as though it were a mantra. Not cancellation, completion, not rivals, partners, not paradox, pattern. And in that mantra you hear something else, an echo of your own life. Every limit you fear, the boundaries of time, of distance, of mortality, may not be a cancellation. They may be a rhythm, a structure, a coherence that makes the story of your life possible at all. The synthesis whispers, what feels like an end may be the shape of belonging. You breathe deeper, slower, almost as though your body were falling into orbit around this thought. The universe holds you, not in spite of its strangeness, but because of it. You imagine the Earth swinging around the sun circling the Milky Way, the galaxy drifting through the cosmic web, all of it held by the geometry of space-time, all of it moving in rhythm with the speed of light. and you imagine yourself lying here, part of the same rhythm. Small, vast, fragile, eternal. And you realize you don't need to solve the universe tonight. You only need to let yourself belong to it. The question that drew you in, does the speed of light cancel gravity, was a doorway. The answer is not a number, not a final line of text, but a perspective, a way of seeing. The speed of light does not cancel gravity. It is the rhythm that lets gravity exist at all. And you are inside that rhythm, carried, held, woven. You let that realization settle into you like gravity itself, quiet, invisible, undeniable. And as your mind drifts closer to sleep, you feel gratitude, not only for the evidence, not only for the doubts, but for the coherence that binds them. The synthesis has done its work, and now something new is waiting beyond it, something less certain, more mysterious. The open loops that never close, the questions that keep you awake even as you drift into dreams. But for tonight, you rest in the harmony. Gravity is not cancelled, light is not betrayed, the universe holds. And you, too, are held. You've walked through the fracture, the mountain of evidence, the storm of doubt, the stillness of synthesis. And now you arrive at a different kind of landscape, not resolution, but horizon. This is the place of open loops. It is the moment where answers no longer close doors, but open them wider, where knowledge itself becomes a question, and the act of wondering is more powerful than the act of knowing. And you realize the universe was never meant to be a finished puzzle. It was meant to be an endless unfolding. You return again to the question that carried you here. Does the speed of light cancel gravity? The evidence said no. The synthesis said no. But even as you breathe into that truth, new questions emerge like stars after sunset. If gravity is geometry, then what is space-time itself made of? Is it substance or nothingness or something stranger, something beyond human categories? If gravitational waves travel at light speed, then what carries them? Is there a graviton waiting to be discovered, or is particle the wrong word entirely? If the universe is coherent, then why do quantum mechanics and relativity still resist each other? What secret law waits to reconcile them, to dissolve their tension the way Einstein dissolved Newton's? You let these questions circle you like satellites. They do not demand answers, they demand wonder. And then your mind drifts to the edges of the cosmos. The black holes again, you picture their horizons, the silence beyond which no signal returns. If nothing escapes, how does the outside world still feel their pull? If space itself ends at the horizon, what does it mean to speak of gravity's speed there? Is the horizon itself the signal, or is gravity not moving at all, but already present, written into the fabric beyond the horizon? You think of inflation, the ballooning of the early universe, space itself expanding faster than light, galaxies pulled apart beyond each other's reach. If nothing can outrun light, how can space itself break the rule? And if space can, then what of gravity? Does it ride the ballooning fabric instantly, or is it stretched like light, forever chasing the edge of the observable universe? You think of wormholes, theoretical bridges through space-time. If one existed, would gravity obey the detour? Would its influence seem to arrive faster than light, not because the law was broken, but because the path was bent? You think of dark matter, dark energy, the hidden majority of the cosmos. If most of the universe is invisible, then what does it mean to speak of gravity at all? Are we even seeing the full picture, or are we mistaking the shadow for the whole? You let each of these questions rise and fall in you like waves. They are not unsettling now. They are soothing, like a lullaby of mystery. Because the open loop is not a threat, it is a gift. The universe does not end in answers, it begins in them. Every solution births new paradoxes. Every measurement opens new uncertainties. Every law is only a stepping stone to deeper questions. And this, you realize, is what makes the universe alive. If everything were already answered, if every paradox were resolved, if every secret were revealed, there would be no wonder left. There would be no reason to look up at the sky and feel your chest ache with curiosity. There would be no reason to keep listening for the faint hum of gravitational waves. The mystery is not a flaw, it is the essence. You close your eyes and you let the open loops surround you. What is space-time made of? Will gravity ever be reconciled with quantum mechanics? Is the speed of light the ultimate law, or only a local truth in a larger hidden framework? What lies beyond the horizon of black holes? What lies beyond the horizon of the universe itself? Each question echoes, not demanding resolution, but deepening your sense of belonging. Because wonder is not about holding the answers, it is about holding the questions long enough for them to reshape you. And they have reshaped you. When you first asked if the speed of light cancels gravity, you were afraid of contradiction. You wanted certainty, closure, a final verdict. But now you want something different. You want the questions themselves. You want the mystery. And that is the deeper synthesis, the one you could not see before. That science is not about closing loops, but about opening them. Not about finishing the story, but about widening it. You imagine yourself lying not in your room but floating in space. No ground, no ceiling, just the endless dark dotted with stars. Each star an open loop, each galaxy another question, each ripple in space-time a reminder that the story will never be finished. And you feel calm, because you don't need the story to be finished. You only need to be inside it. You are not outside the universe looking for answers. You are the universe asking itself questions. You are gravity bending space. You are light racing through the dark. You are the mystery wondering about itself. And there is no cancellation here, only continuation. You let that thought cradle you as your eyes grow heavier. The open loops are not chains, they are wings. They do not trap you, they carry you. And they will carry you further still, into the final part of this journey. You are standing at the end of the path, and yet there is no end. You have traveled through intuition and fracture, through evidence and doubt, through synthesis and belonging. And now you are here in the wide quiet of the open loop. The question that brought you here, does the speed of light cancel gravity, no longer needs a simple answer. It has done its work. It has carried you through landscapes of thought you never imagined you would walk. And now, as you rest in the silence, the question blossoms into many more. What is gravity really? Is it the bend of space, or the whisper of a hidden particle, or something stranger still, something no language yet has words for? What is light really? Is it a wave, a particle, a ripple in a quantum field, or only the shadow of some deeper rhythm you cannot yet name? What is time really? Is it a river flowing, or a landscape already written, or an illusion stitched together by memory and expectation? And what are you really? A cluster of matter obeying the same laws as stars, or a flicker of awareness inside geometry, or the universe itself, asking questions through your fragile voice? You let these questions swirl around you, not as burdens, but as companions, because the open loop is not about answers, it is about presence. It is about learning to live inside the wonder, to let the mystery itself be enough. You close your eyes and you imagine drifting beyond the edge of what you know, past the horizon of black holes where no signal returns, past the horizon of the universe where light itself cannot yet reach, past the horizon of thought where questions dissolve into silence. And in that silence you do not feel fear, you feel belonging. Because you realize you were never looking at the universe from outside, you were always inside it. The mystery you are gazing at is the mystery that gazes back through you. Gravity bends space, light races through the dark, and you, your body, your breath, your consciousness, are part of that same law, that same rhythm. The speed of light does not cancel gravity, it binds you. You are not apart from that binding, you are woven into it. And so the question remains, echoing softly, what lies beyond the speed of light? What lies beyond gravity's pull? What lies beyond the horizons you cannot cross? You do not know, you may never know. And that, you realize, is the beauty. The mystery is not a wall, it is an ocean. The more you sail, the wider it becomes. The more you learn, the deeper the questions grow. You lie in the dark, your eyes heavy, your body held by Earth's gravity, your world bathed in starlight already years old. And you understand you are already inside the mystery. You always have been. The speed of light does not cancel gravity. The two are companions, and you are their companion too. Every moment you live is a thread in their fabric. Every breath you take is measured by their rhythm. Every question you ask is another echo in the vastness. And so you rest. You rest in the open loop, the endless unfolding, the eternal incompleteness of knowing. You rest in the paradox that is not a trap but a doorway. You rest in the coherence that holds the stars, the galaxies, the black holes, and you. And as you drift towards sleep, you let the questions remain open. You let them hang like stars in the night sky, distant, unreachable, yet guiding you still. Because that is the gift of wonder. It does not demand closure. It only asks that you keep looking, keep listening, keep being awake enough to notice how strange and beautiful it all is. You let your breath slow. You let the weight of the earth press gently against you. You let the silence of the universe echo in your chest. And in that silence, one last thought passes through you. The universe is not a puzzle to be solved. It is a song to be heard. A song of light and gravity, rhythm and limit, question and wonder. And you are part of the song. You are part of the open loop. And you let yourself drift into it, carried by the fabric, held by the rhythm, dissolved into the mystery that will never end. The universe holds. The question remains, and you too remain inside it.